Hello, my dear learners. I hope you are fine and you're taking precautions. Today, we are meeting again on our series of lessons. Last time when we met, I promised you that when we meet today, we are going to discuss about efficiency. But that is after we had discussed about what we call mechanical advantage, which is represented by capital M and A. We said the formula for calculating mechanical advantage is load force divided by the effort. If you remember, you can go back and check on the YouTube videos. We also discussed about the velocity ratio, whereby we said this is the ratio of the effort distance to the load distance. And then we came up with a formula which says velocity ratio is equal to the effort distance divided by what we call the load distance. Just as a reminder, we said effort distance can also be called effort arm. Load distance can also be called load arm. So therefore, the other formula for velocity ratio, instead of using effort distance, you can use effort arm. Load distance, you can use load arm. That is just a reminder of what we had discussed. And we had some very many examples and calculations that we did. Please, don't forget to go back and do your calculations so that you can master them and understand on how to calculate for mechanical advantage and how to calculate for velocity ratio. So, come with me. We discuss about efficiency now. What is efficiency? Efficiency is the ability of the machine to perform its best. The ability of the what? The machine to perform its best. When we say something performs its best, it means it makes work easier. Remember, what is a machine? A machine is any device that simplifies work. So, the ability of the machine to perform its best is all called what? Efficiency. And now, when it performs its best, what does it save? What does it save? It saves what we call time, it saves what we call energy, and what we call effort. Remember, when you use a lot of time on something, that is wastage of time, isn't it? When you use little energy, it means the machine is perfect. But when you use a lot of energy, what do we mean? The machine is not perfect, isn't it? Now, this efficiency has another meaning, which says it is the ratio of the output to the input. We shall see what output means and what input means. But go with me again. We said efficiency is also the ratio of the output to the input. The ratio of the output to the input. Now, what is output? When somebody tells you output, it is the amount of work done on the load. The amount of work done on the load. That is why if you look at this one here, I've said that now output is equal to what we call what? The load force times the load arm. What is load arm? You remember? Load arm is the other name for load distance. So the product of the load force times the load distance is the same as output. Output is the amount of work that is done on the load. Please get note of that. What about input? Input, it is the energy used by the machine, the effort. Alright? Whereby now input can also be calculated by getting the effort force times the effort arm, or effort force times the effort distance. So my dear learners, we go back here, we say that efficiency is the ratio of the work done on the load to the energy used by the machine, meaning that the ratio of the output to the input. Thank you very much. Now, remember, when we were calculating mechanical advantage and velocity ratio, we had no units. Mechanical advantage had no units, velocity ratio had no units. But now, when we come to efficiency, efficiency is normally shown by what we call percentage. And you know very well, the sign for percentage is right there. Now, the percentage of efficiency of a machine is usually less than 100%. Meaning that not every machine is perfect. Okay, you get the point. But now, if you get a frictionless, I think you understand friction. Due to friction, that is why the percentage of the efficiency of a machine will not be 100. But if you get a machine that is frictionless, that is when we say a frictionless machine has an efficiency of 100%. But most of the machines have the efficiency that is less than 100%. Dear learners, get note of that. Okay. The formulas for calculating efficiency are three. They are three. One, efficiency can be calculated by dividing the output over the input times 100%. I will not remind you what output means or what input means because we have discussed it. Efficiency also can be calculated now by load force times the load distance. If you remember, we said output is the same as load force times the load arm. So this is standing for output. So instead of using output, you can still use the formula. Load force times load distance over the effort force times the effort distance. But don't forget to multiply it by 100% because it has to be shown by percentage. Thank you. The third formula for calculating efficiency is the mechanical advantage over the velocity ratio times 100%. How do you get the mechanical advantage? Go back and check. Load over effort. Velocity ratio, effort distance over the load distance. So if you get that, multiply by 100%, you'll be getting your efficiency. Now, class, let us do some few examples of calculations. Question 1, it says, a load of 350 Newton is raised 0.5 meters by a machine in which the effort of 325 Newton moves 0.8. Find the efficiency. Which formula do we use here? You can choose. We can even use the first one. The first one says efficiency is equal to the output over the input times 100%. Now, the output is the load times the load force. Now, a load of 350 Newton. That is our load force, 350 Newtons times the load distance is 0.5 meters over 325 Newtons times 0.8 meters, then times 100%. Okay, we can now simplify this. We simplify this, put this one. 5 goes there 65. 5 goes there 70. 5 goes there 13. 5 goes there 14. I have 14. I have 14. I have 14 times 0.5 times 100% over 13 times 0.8 meters. All right. Now, this 100 can make the decimal point to move one step. I'm going to have 14 times 5, which is 70, times that 10 is 700 over 13 times 8. It is going to be 24. 8 plus that is 10, 10.4. Then times 100 times 10 there, times 10 there. So I have 700, 7,000 divided by 104. Yeah. So from there, you can divide this and then get your what? Please, let's come to this side. We can use this side to complete this question. Yeah. So I have 7,000 divided by 104. How many times? Times 5, times 6, yeah, times 6. Take 6 there, which is 24, carry 2, 2, and that is 6. When you minus, we get 6. We get 7. We drop that. How many times again? 7. It goes there, 28. 2, and then there 7. When we minus, we get 2 there, there we get 3. So you can leave your answer as a fraction, which is 67 and 32 over 104%. You can simplify that, but for now, let's leave that answer at that point. That is question 1. Let's go to question 2. After getting the answer for question 1, let's go to question 2. It reads, we read together, a mass of 160 kgs is lifted a height of 12 meters using an effort of 80 kgs which move 40 meters. Calculate the efficiency. The efficiency, please, let me use E to stand for efficiency for now, goes, it is now the load force times the load distance over the effort force times the effort distance, then times 100%. What is our load force? Our load force is 160 kilograms times the load distance is 12 meters over the effort force is 80 kilograms times the effort distance, which is 40 meters. Now, we can simplify. M with M, kg with kg. Don't forget, it is times 100%. 0, 0. 8, 1, 8 goes there, 2. 2, 1, 2 goes there, 20. Then, if I divide this, 21, 20 goes there how many times? 5. Now, 12 times 5 is equal to 60%. So, the efficiency of that machine is 60%. Question 3. By using a machine, an effort of 30 Newton was moved a distance of 15 meters to raise a load of 120 newtons to a height of 3 meters. Find the efficiency. Find the efficiency. Efficiency, somebody to remind us, efficiency is equal to what? Either output over input times 100% or load force times 100 or mechanical advantage of times 100. You can see the 3 formulas on the board. Which one do we use this time round? Let us continue using the second one, whereby it is the load force times the load distance over the effort force times the effort distance times 100%. What is the load force? The load force from the question is 120 newtons times the load distance, it is 3 meters, over effort of 30 newtons times the distance is 15 meters times 100%. Let us simplify this. 3 goes there, 1, 3 goes there, 5 meters with meters, right? 0, 0. 3, 1, 3 goes there, 4. 5, 1, 5 goes there, 20. So 4 times 20 is equal to 80%. So the efficiency of this machine is 80%.